In this video, we're going to take a look at some of the most common families of equations found in all of mathematics. The specific equations that we're going to look at are the linear equations, quadratic equations, square root equations, reciprocals, and absolute value equations. Now for each of these, we'll look at a basic representative or one of the most basic equations you could have from that family, as well as look at its graph and table of values so we get a better sense of how all of these work. All right, let's take a look at the first one just to get a sense of what I'm talking about. All right, so the first of these we're going to look at, these will be our linear equations. And a really good way to distinguish what a linear equation even looks like would be that they all form a nice straight line when you're looking at their graph. So a nice, good, or basic representative of these type of equations is the equation y equals x. And you can see from its graph that it definitely has that really nice straight line shape to it. It starts in the lower left and goes to the upper right as we're looking at that graph. Now, since its equation is fairly nice and simple, y equals x, what we see in the table of values is, whatever value we have for x, that's the same value that we get for y. So these things are exactly the same for that y equals x equation. All right, not too bad. Let's take a look at the next one of these. The next of these will be our quadratic equations. These have a very nice and distinctive shape. They have a nice U shape to them. Now that U-shape could be facing up or could be facing down, but all quadratics will have this very nice U-shape to them. So when it comes to a good representative for this family, y equals x squared is a perfect example of a basic quadratic equation. And sure enough, we can see in its graph, it has that distinctive U-shape to it. It starts here, what we would say at the vertex at 0, 0, and really goes up in both directions from there. Now what we're seeing in the table of values is really that squaring process. So whatever x value ends up inside of this equation, it's getting squared and becoming positive. So something like -1 becomes +1. Throw in a -2, that gets squared, it becomes a +4. All right, not too bad. The next of our families we're going to look at is the square root family. These ones are very interesting. Sometimes they look like they're leveling off or they're getting really shallow. But surprisingly, they are not. They are actually always increasing if you're reading them from left to right. So a good representative to get a better sense of what I'm talking about would be y equals the square root of x. And I've graphed that below onto its graph. Sure enough, it looks like it might be leveling off over here, almost like the upper half of an airplane wing, but it's not. It really is getting bigger and bigger as we get further and further out. It's just doing it very slowly. So when it comes to this graph, we can definitely see that it seems like there's some missing values over here on this portion of the graph. Now, those values are not missing. It's simply that we cannot see them since we're only graphing real numbers. But I'll be a little bit more specific. Since we're dealing with stuff like square roots, if we were to try and put in things like negative numbers, these are not these do not produce real values. So that's a bit of a problem since our graph only contains real values. What that means is values like -1 or -2 don't show up on our graph. So you're going to see that they are missing on our table and they are not written on our graph itself. So actually that tends to be a fairly distinctive feature of things that contain a square root, is they'll have whole regions of values which simply are not defined because they might have a negative underneath that square root. All right, moving on to the next one. The next of these will be our reciprocal equations. These are really formed when we're dividing by our variable x. So a really great candidate to look and learn more about this family is the equation y equals 1 divided by x. So fairly simple, but we can see that this graph is very different from some of those others. As we're looking at the graph, it looks like it's getting close to a couple of straight lines. These arms of the equation itself, that looks like it's getting really close to that y-axis and the x-axis. That tends to be a distinctive feature for these reciprocal equations. Now in terms of missing values, this also has a missing value. We can see it on the table right there if we tried to use x equals 0. And of course that happens because if we were to try and plug in x equals 0 into that equation, y equals 1 divided by x, well, we can't divide by 0, so this becomes undefined, or we could say that this does not exist. So keep in mind that it has a missing value similar to those square roots. However, it's usually just one missing value coming from only a single value being undefined in that equation. All right, and let's go ahead and take a look at the last of these. This would be the absolute value equations. All right, like a lot of the others we've seen, these have a very distinctive shape. These have a wonderful V shape to them. In fact, they're very similar to our linear equations, but they do usually have that kink or corner in them. A good representative for this family would be the equation y equals the absolute value of x. So here I have a graph below, and sure enough, it's got that very nice V shape to it. This is very similar to our graph for y equals x. You know, that would have an additional line just along the bottom there. The only difference, or the reason why that is now flipped up, is because the absolute value is taking those negative values and now making them positive. And sure enough, we can see that in the table over here. If I was to put in something like a -2, this absolute value would make it positive and turn it into a +2. So it's simply doing that with all of our x values to produce the specific y values. All right. And those are some of the most common and basic equations you could see in all of mathematics.
Hey guys, my name is Jess, the head of education here at Wise. I hope you enjoyed this video tutorial. If you want to see the complete course, please check out the link in the description. You can also go to one of our playlists to keep learning for free. If you want us to cover a specific course or a specific topic, please leave us a comment below. We post new videos every week, so don't forget to subscribe so you don't miss out on any of the new stuff.